Welcome back. We've turned the final corner and we're in the home straight now, I think, with one more panel and then one more speaker to close out the conference. So I'd like to introduce, please, Dr. Sinead O'Connor. Sinead Meehan.
You literally just tested.
Just
Thank you. Yeah.
That's that will have been a very interesting panel. Junaid spent much of his time undertaking pathfinding R&D, and specifically focused on strengthening MOD's space capability. He's spent a lot of time supporting the space architecture work that's going on at the moment, and also provides support into the Directorate and the Space Command, particularly focused on addressing the more critical challenges that they face. He is the person that delivered the government's first owned and operated ground station and mission operating centre. So a very esteemed panel lead for this session. Over to you.
Thank you very much. We've had quite a few excellent panel sessions today, focusing on S&T and some of the challenges and capabilities we're trying to develop. We've had some really good engagement discussions on how we can bring in industry and academia into supporting defense and space. And we've also had some insight into the policy and the legal challenges that we could have trying to promote UK space for our own national prosperity. We're going to shift gears a little bit to think on the word collaborate and how we collaborate at an international level to promote resilience for our future space requirements. And I'm absolutely honored to have this incredible panel sat with me in person and also virtually as well, just to show that we can do IT together. And I'm going to give an opportunity here for the panel to introduce themselves, their organization, and also what current S&T work are you trying to promote and develop at an international level collaboratively? So I'll start with you, Dan.
Okay. So good afternoon, everybody. My name is Colonel Dan Galton. Go by Shooter. That's my call sign. There's a story behind that. Happy to share it for a beer or gin and tonic. A little bit of background about me. My education, doctorate in space physics. So with respect to the last panel, I wholeheartedly agree space physics is fundamental to everything that we do. A little bit of experience. You see, you saw at one point that I had a title. So I wear several different hats. I'm currently in command of one lab that supports two services. So I'm a little unique in the fact that I am now a Space Force colonel leading an Air Force research lab. We focus on the basic science. And what that means is really that fundamental research, that discovery research, high risk, high reward. Looking at those time horizons of 5 to 10 to 15 years, right? When we really want to focus on the revolutionary and the evolutionary, but we also want to get insight into those game-changing technologies, both from making sure that we have them on our side, but also trying to avoid that technological surprise from our peers. We work very closely with a lot of our international partners. We have a domestic portfolio. The domestic portfolio has 1,200 grants. So I work with a lot of the universities. I also let 200 contracts per year, and that's with our industry partners. These are usually smaller dollar amounts, and it is an incredibly diverse set of science and technologies that we look at. My space portfolio, although near and dear to my heart, and that's what I spend the majority of my time, energy, and passion on, I also have 80% of my portfolio that is not space. So I have to show love to the rest of my scientists and engineers. So I have 36 diverse portfolios ranging anywhere from complex math to materials to biomechanics to biotechnology and so on. So we do a lot of very diverse things. My international colleagues that I work very closely with, we partner with over 43 different nations and work and support and grow that technology together. So I work very closely with a lot of my applied research colleagues. I focus quite a bit on a lot of the tech demos, and so that's also near and dear to my heart. So I try and juxtapose the long term with the short term because it's very critical to get capability out to the warfighter. I'm going to talk very briefly about another hat that I wear. I am a subject matter expert or a space member at large, as they call it, for NATO. So I lead multiple S&T activities on behalf of the NATO alliance. that has carried over from a previous job. So shout out to DSDL that has supported me on several ongoing activities. But I think that's enough for now. I'll let you speak, Deanna.
Thanks. Hi, good afternoon. I'm Deanna Riles. I'm the Director of International Affairs at Space Systems Command out in Los Angeles. Probably the least technical person on the board today, so I'll avoid those questions if I can. But it's great for me to be here at a conference we heard yesterday where the theme is Allied by Design. That is exactly what I do every day at work, is look for solutions to hard problems in space with an allied mindset first and foremost. Much like the UK's own Collaborate and Access, we talk about acquiring capabilities with a borrow, build, then buy. I'm sorry. Ooh, I get in trouble for that one. Buy, borrow, then build. Or as Lieutenant General Gutlein would say, exploit what we have, buy what we can, build what we must. But for everything that we do, that is underpinned by looking at what we can buy, borrow, or build together with our allied partners. And a lot of that starts with looking at the need for capabilities that are going to be resilient, building a resilient architecture, building an integrated architecture with our allies. And for us, everything starts with the force design. So we, in the US Space Force, stood up a new organization called SWAC, the Space Warfighting Analysis Center. They're working through force designs in each of our mission areas right now that are threat-based and focused on getting capability as fast as we can out the door, but looking long-term for what we need. That's really where I think the S&T community can help us as we develop these force designs. We're looking at the threats, we're trying to decide what we need. We'll drive an architecture, but then it's up to the acquirers to figure out how we're going to go acquire that capability to fill that architecture. So that's what we're doing out at Space Systems Command. As I said, in every element of what we do, we're looking at how can we do this with our international partners. When we talk about Allied by Design back in Space Systems Command, we're trying to make sure that at the very inception of an acquisition program, we build that for integrated operations and partners who are going to want to join that. So that goes into the very beginning of the design, it goes into the requirements, it goes into the build concepts, it goes into what we're going to buy, if we're going to buy something, how that decision is formed. So it is really, I think the US Space Force in general is going to be allied by design, and that's our responsibility at Space Systems Command to procure those capabilities. Thanks.
Hello everyone, so my name is Ben Colton. I'm here representing Inmarsat. For those who don't know, Inmarsat is a leading UK satellite communications operator, and we really specialise in providing mobile global communications to over around 80 governments around the world, both in land, air, sea, but also in the space-to-space domain. I'm also here representing the Athena Group, or Team Athena, and that's a collaboration between Inmarsat, CGI, Serco, and Lockheed Martin. And we're here to really leverage the deep experience we have in the space domain to address the biggest challenges and opportunities in the defence market, and also with a view to STEM programs as well, which was nicely referenced earlier, so thank you for that. We were asked as well in terms of providing examples in terms of S&T and how international collaboration works with that. And I think a good one is the recent Communications and Services project through NASA, the CSP project. And that is about looking at replacing a sovereign-owned asset or network, the TDRS network, with commercial services so that NASA can then focus funding and CapEx on other programs. Inmarsat were, along with some other operators, were awarded some S&T program, mainly for Inmarsat to look at how we can use in-orbit telemetry relay using our GEO network that's in place today for launch vehicles. But I think where this example is really important is that contract award with NASA probably wouldn't have happened without engagement with the UK Space Agency in prior feasibility contracts through the NSIP, but also with the international NSIP, where we collaborated with MHI, the Japanese launch provider. So I think it's a really important example about how these different S&T programs that the UK space industry has access to can really lead and have a domino effect in terms of avoiding that valley of death that was talked about earlier. So happy to talk about that further.
Hi, I'm Nick Smith. Firstly, just want to say thank you for the opportunity to speak, but also thank you to the organisers. I think with the amount of space conferences going on, it's always hard to distinguish, I think, between the different conferences. I think it's worth just mentioning this one, I think, has brought up some very different subjects than we've seen previously, and I just want to commend everyone involved in making that happen, and hoping my involvement doesn't undermine the good work that's been done to date. I would do an introduction, but quite frankly, after Robert from Maxar yesterday won biography top trumps, I'm not going to go there. I'll just remind myself about how I've wasted my life to date. So I will talk about Lockheed Martin, which I think is why I'm here. For those, most of you will probably know, Lockheed Martin. I think you can tell by the fact that I'm wearing a tie and I've got to wear glasses to read my notes means that I'm not new space. I'm not going to use old space. I'm going to go with distinguished space, if you'll allow me that one, where that sticks or not. But one of the oldest space companies, decades of experience, right from the early stages of doing the first ever remote sensing satellite, which used wet film, and they used to drop that. And what's really interesting, of course, is the same technology they used to recover that wet film in midair actually has applicability today. And we demoed that up in Scotland in 2016 to think about how you could use it to recover first stages of rockets. But we do everything from that through to a number of different patents as well, about 3,300 global patents as well, which shows you just how we're sort of a strong background in engineering as well. As far as capabilities go, everything from sort of the cutting edge on things like hypersonics, but also a lot of things we're known for, which is around some of the exquisite technologies. And this is where I make some joke about being watched over by the NRO. I'm surprised someone hasn't made that joke already. Those sort of exquisite satellites, but also the other end of the spectrum, which is a lot on space sciences. And to give you an indication about how my sort of job differs, I think last week I was here with a team who are looking at things like how do you protect assets in orbit for security missions. But then a couple of weeks before that, I was doing a podcast with one of our specialists, Cassie Lee, on space sustainability and climate intelligence and how space actually contributes to that. And what's really interesting is earlier on, Anu sort of showed those two views, the defense versus academia. Well, we actually have some of that tension directly in our organization. And I mentioned Cassie earlier. And what's really fascinating about Cassie is she struggles a little bit with one side of what Lockheed Martin does, but she joined Lockheed Martin because she felt it was the only organization that had the scale to be able to deliver the ambition that she wanted. She came from not-for-profit organizations and came to Lockheed Martin because she felt that's where she could make a difference. And it was really fascinating to get that insight. Pretty much everything from one, across the whole space value chain, and also from a UK perspective, involved in the UK launch program as well, and happy to take questions on that. I think before I sort of go on, I think the questions that we go through in the discussions, we can talk about how Lockheed Martin engages in S&T internationally. But I think I just want to quickly unpack the questions slightly as well to try and list some questions and discussions. A couple of things that I think are really interesting about this question that would be good to have a discussion around. One is the statement integrated resilience. I'd really be keen to try and explore what we mean by integrated resilience. Do we mean resilience in the supply chain, which I think is a live issue right now? Do we mean resilience in the sector itself, which I think is more about the sustainability? How do we think about what the sector will be in 20, 30, 40 years? Do we think about resilience in skills? And again, something Anu brought up earlier, which again, how do we make sure we've got that workforce we need to do the things we want to do? Or do we talk about resilience sort of about the assets themselves and how we provide the security for those assets, which quite frankly, to do correctly, has to be integrated. You have to think about all elements of your activities in space to make sure those things are protected. So it'd be interesting to have a conversation around that. I think the other one as well is just S&T. What do we mean by S&T? And I think we conflate a lot of issues as well. We've got S&T in the title here, but I think we're going to touch on S&T, R&D, innovation. And I know a lot of people say, well, that's semantics, you're dancing around. But I think there's some nuance in each of those, which I think is worth exploring as well. And it'd be good to get some questions about that. Absolutely.
Thank you, Nick. And Jim, hopefully you can hear us. And just for awareness, you are being depicted as an overlord to the entire panel. So you have full control.
Well, not to unsettle folks, but yes, you do have the NRO peeking over your shoulders.
Not the first time.
Yeah, no, I'm very glad to be invited to this panel and glad to contribute. My name is Jim Beckwith, and I'm the tech director within the Advanced Science and Technology Division, or actually office, within the National, or division within National Reconnaissance Office. And I focus in several areas: innovation, tech maturity, and other really important one I just forgot, and technical assessments. That's where we independently take a look at the technology that is being developed to fly in space, and take a look at it two ways. One thing is to look at, is it ready for space, which is a very difficult place to operate, as the panel well knows. And then the second area is what is developed pretty far along technology-wise, but it's not quite ready for space, and what do we need to do to push it over the edge to get it there? To accomplish this, we work across a broad range of areas. We work with academic partners quite a bit there. We work with industry partners. We work with other folks within the United States government, and then internationally with folks such as over in England, such as your organizations, and other people around the world. And really, these days, you have to have partnerships and work together to be successful and to achieve the goals that have been laid out for this panel to discuss of how we get there. Very, very.
Thank you. So I'll kickstart the panel discussion with one just from the online audience. And it's one that I think we're starting to face now, more so than ever with the setup of Space Command and Space Directorate. And that is, what cross-government challenges do you think are inhibiting our coherent collaboration? So you can take that from within the US with the different departments that we have and the cross-government challenges that you have there, and then engaging with us from the UK. And for our industry colleagues, what is the government to industry inhibitors that are limiting our coherent collaboration at an international level? So I will start with Dan.
Okay, so that's a great question. There are a lot of different nuances to that. The way that I kind of look at the ecosystem is there are a lot of stakeholders, and so I have a lot of conversations about what we are trying to do. The challenge that I see as I look across the spectrum, and this is from the basic science and technology piece, but it's also at the more advanced applied tech demo, is understanding what the operational requirements are, understanding what those future architectures are. Right, so as I look at cross collaboration in terms of an international perspective, trying to identify where we are moving together collaboratively and where we are moving together individually, just so that we have transparency and open communications. One of the things that we tried to do from a NATO perspective was about a year ago was have a roadmap discussion of where are those near, midterm, and far-term S&T challenges, gaps, and opportunities. Right, and NATO is very different, as many of you are aware. NATO doesn't tell you what to do, they just make strong suggestions, right? So we, at the end of the day, we had to prioritize a list of recommendations. And what that does is that provides a series of it's a roadmap with a series of markers on it that kind of prioritizes where we want to invest. And I think if I look at it across the intergovernmental or with my international partners, that is where we need to probably improve upon the conversations, identifying what those clear requirements are. I think it's great, and we all realize that we all have sovereign capability that is unique to our particular mission sets, but where we can discuss, right, and break down those cross-domain barriers, right, that we put in place with the caveats and with our special programs, where we can have those conversations and put forums such as this, where we can engage in that meaningful dialogue. I think that's how we start to get to the heart of the problem.
Thank you. Deanna, do you?
Yeah, for me, it's simple. It's culture. It's a culture of trust and a culture of no. That's the culture that we live with today, whether we're talking about trusting our commercial providers to provide capability that isn't built by the U.S. military and the U.S. industrial base. It's a culture of not trusting our S&T community. Can they really solve the hard problems? How long is it going to take to prove out? How do we onboard that? I think it was a great discussion earlier in one of the panels. And how do we get after a very congested environment? And how do we do that with a system that we're going to trust? So for us, I think that is the biggest thing. It's cultural. We have to get over the cultural impediments. We have to be ready to work with our allies. We've got to be ready to share everything we can. We've got to be able to engage our S&T and R&D communities throughout the process and get those great ideas. So for us, we're very focused on delivering capability to get ahead of the threat. The threat is in 2026 from the way the United States looks at it. We have to deliver as much capability as we possibly can between now and 2026. And in order to do that, we have to trust our partners, our allies, our industry, our R&D and S&T community. It's going to take all of us together to deliver that kind of capability in those timeframes. So to me, that's the biggest impediment.
Thank you. Can I just pass on to Jim just to get the final U.S. government perspective?
Sure. I agree with those comments completely. One thought I had here is that you also, much as academia would do, you need to set up experiments and run them and test them and see how it works out. An example there would be work on a common goal together and make sure that your ground can reach up to the satellite and communicate with it, and that the information can be shared among your partners that are involved in this, and that the satellite is operated properly and developed and launched successfully. And these days, we really don't allow for many failures, but when we first started out in space, I remember many videos of this rocket crashing and burning and all the rest, and we've gotten very used to you push the button, the rocket goes up, and it all works. That's not a guarantee. It takes a lot of preparation ahead of time to make that work. And we have to accept that there is risk up there and work together as a team and collaborate to bring that risk down as far as possible, but make sure we achieve the missions that are required of us.
Thank you, Jim. Ben?
I think it's communication awareness, but at a high international level. I think in previous discussions, it's been brought to attention that nationally, doing civil and military programs, sometimes there's a disconnect, understanding the value and reuse that we're doing S&T in like an ESA program or an NSIP program. How can that translate to DSTL, etc.? But then to take that up to the higher level, and for UK government to say to our partners that we're doing these S&T programs, what's the relevance? How does it sit within your strategy? And is there a reuse at the international level? And then it was interesting you were saying, Deanna, about the trust, and it comes down to sometimes the commercial element as well, where normally you have to have, you need to be a national vendor and all of these types of things. So how can we break that so that we can innovate faster and deliver faster as well?
Nick, do you have anything to add as well?
Well, the great thing about going last is I can just steal everyone else's answers and try and pass them off as my own, can't I? Look, I think there are a lot of practical things, which is the information sharing internationally I think is a classic one, and then even across government, there's always that question about who owns priorities on requirements and how do you set those. I mean, that always exists. But I think for me, it's Deanna's point, which is what I'm just going to reflect on a little bit. Is many decades ago, I was in the military, and I remember turning up to Cranwell many years ago, and of course there was a picture there of Frank Whittle designed the jet engine, and that wasn't government and industry. That was one team working together. And I think what's happened over the last few years for that, why is that relationship eroded in some ways? I think academia can be included in that as well. We've seen divisions between these organizations, and I think it does come down to trust. There's something about the trust between those different organizations, and it has eroded over time. And I'm sure there are many reasons for it, and I think, again, I'm going to steal something coming from another panelist, and I think when we look about how we're going to solve that, I think Jeremy from the last panel, I think he hit on a couple of things really keen for me. I thought one was around leadership and confidence in leadership, and something about the commercial side and how do we get that commercial, as sort of Ben was alluding to there, how do we enable that commercial to do it? And I think it all comes down to the fact that there seems to be this lack of confidence in their own ability of many of these people on the government side to go forward and take the risks and understand where those risks really are and then drive that down through the organization. And I don't know when that's been lost. And I think there's something really key in that. And I do hope that the space sector policy, I think that's what we're still calling it. I think when that comes out, I hope that will be bold and be ambitious. And I hope that the people writing it will have the confidence to do something really quite innovative in there, because I think that's how we're going to unlock a lot of this and maybe bring those organizations together, which then the collaboration will come, the risk assessment will come, the comfort with taking some of those risks will come. And then I think we'll see some real difference.
Can I add on to that, please?
Yes, of course.
That's a disadvantage to going first, right? Prompts the other thoughts. One of the other pieces that I think it's worth bringing up to the audience here is we need to change a paradigm for how we do business. And I mean that leveraging what Deanna said in terms of changing a paradigm is changing how we shift, right? We have to be willing to accept failure, right? That's changing the risk management piece. But I would offer up, it's not accepting risk, right? It's transferring or mitigating risk, right? So if I'm stealing the theme from innovation, it's how do I innovate? How do I fly? How do I fail quickly, right? Not tremendously, but we all fail. Right? There's no innovation without failure. And then how do I learn from that? Right? And that's one of the things that we try and do on a tech demo piece is let's fly quickly, let's learn, and let's iterate. Right? That's the only way that we're going to get in front of our adversaries. We have to increase our decision space or shorten our decision timelines on a much faster, shorter timeline than our peers.
That's an interesting point. I'm going to open more questions to the audience here, but just to follow on that, do you think from your perspective, and you as the panel, do you think there's more of a risk appetite towards industry S&T than as opposed to academia, or do you think there's an equal balance there?
Do you want to start, Dan?
Well, it seems fair that interesting. I think it depends on the organization, quite frankly. I think every organization is different. And there's some conversations earlier about the difference between the smaller organizations, the SMEs, and the primes, and I think you see a difference there, and that's all to do with the way they're structured, the risk appetites that exist, the way they're funded, the way they run those programs, which is why they collaborate and work together so closely, and we heard about that, some of that, we can go into that later. So I don't think it's necessarily an obvious thing. I think what I do see happening, though, one of the reasons why I believe the risk appetite is possibly different in government, is it comes out the point earlier, I think, which is there seems to be, especially in the space world, and I'm pretty parochial in my view, is there seems to be a lack of confidence in their understanding of the space world. And possibly we don't see it in other areas where there is a longer heritage of understanding in that area. And I use this sometimes, but the UK for quite some time has had a shipbuilding industrial strategy. It seems to be there are decades of experience, in fact, centuries of experience in shipbuilding, and therefore people are confident to understand the risk and they can get it institutionally. I think in these new segments, new areas, there isn't that same institutional understanding, which means your risk intelligence isn't as high. So your ability to sort of bound and understand that risk instinctively is not as high. And I think that's part of the challenge, whereas maybe industry does understand that risk a little bit better, is able to quantify a little bit better, and that's maybe where you see some of the difference. That's right.
Any follow-ups?
I'm just going to add, I think when it comes to risk, I think companies are prepared to take risk, but we need to be reassured that there's an end goal and that there's a vision. Because at every milestone, you'll have to go back internally and say, we need to make more investment, et cetera, but you have to showcase that there's a purpose to this, and I think that's quite important.
Right. Okay.
So I think there's risk and I think there's smart risk. Right? And so we need to differentiate between the two. I think smart risk are we all understand intuitively what that means. But this is where I'll leverage my NRO colleague. There's also empowerment, being able to push that decision down to the appropriate decision level, right? And the NRO has a unique perspective in terms of pushing it down to lower levels. Where we sometimes are challenged are from a bureaucratic point of view, right? Who's the decision maker? Who has the authority to make the decision and commit resources, right? And so trying to remove some of those barriers, I think, are critical for us to go faster and innovate and accelerate that innovation.
I just add one last thing. Two things I think are going to drive us to a much more accepting risk posture. One, what's happening in the world right now, and seeing companies like Maxar and our other commercial partners that are providing capability to help another nation, right? Their risk just wasn't even a factor. It just needed to happen, so it did.
That's a great point.
So that's one thing. And I think, too, again, the speed of delivery of capability, we have to push as much stuff out the door in the next 2 to 4 years to get ahead of the threats that are out there, the near-peer adversaries, and what we're seeing happening in the real world today is also going to force us into a situation where we're going to have to learn to accept risk, fail fast, and move on. So I think those are two driving factors that are going to get us to that point.
Okay, I'll open the floor to the audience here. If you have any questions, can you just raise your hand? I see one here.
Hi, Dewita Govinji from PA Consulting. This is a question for Deanna. In establishing SWAC, are there any kind of key lessons learned that you can share as Defence Space tries to grow its capabilities? Thank you.
I think the SWAC is relatively new. It's been stood up in the last year and a half or so. So I think we're learning those lessons right now, but they delivered the first force design, which was a missile warning, missile track force design for the U.S. Out of that, the force design that they built completely changed the architecture that we were acquiring capabilities for. We went from a specific GEO architecture to looking at the threats, looking at the capabilities, looking at what commercial providers can bring, change the architecture, and now we're moving to a LEO-MEO architecture for missile warning, missile track. I think that shows that it's a very relevant organization. The analysis is strong. We believe in it, so much so that we're making big programmatic decisions to adopt that force design that's being presented. So I think lessons learned will come from that as we're going through that first one. But I think the lesson that we've learned now is the force design is needed, it's relevant, it's really good work, and it's going to certainly drive the future of our acquisition.
Do you mind if I add on? So I am a SWAC alum. So it is really an optimization model, right? So you can trade off various variables to assess, right? Whether you're looking at performance or cost or schedule, right? And so that gives us an opportunity, as I mentioned at kind of my opening monologue, which was a little long, so my apologies to everybody. But the piece on it is, what are the requirements and what are the architectures that we need, right? And understanding that, I think, is fundamental to how we go forward. If you don't know what you need, what capability you need, then how do you know what to acquire? If you don't know what to acquire, then how do you drive that down to technical and system requirements, right? So it's that flow down that we all do as space operators or acquisition folks. And so that gets to the heart of the question, I think. So as Deanna said, there are a lot of lessons to be learned, but at least we're taking some baby steps to move forward.
Great. So another question from the virtual audience. What challenges do we need to address together to ensure future resilience in the space domain? I know yesterday AVM Godfrey mentioned classification was one of those challenges that we have to overcome, and how we work at different classification levels at the international level. But do you see that as the main focus, or are there any other collaborative S&T areas that we need to work together now to try and address these future challenges? And particularly, what S&T areas do we need to grow going forward as well?
I'll take one start at it. Diversity in the architecture. I think that is the one thing that we have to do. We have to diversify the capabilities that we're bringing in together. We've got to diversify the way we're building things, multi-orbit diversity, purpose-built capability plus commercial capability plus allied capability. That diversification, I think, is what it's going to take to deliver the architecture that we collectively need. So that is definitely underpinned by a number of challenges. Classification is a great one. That's something that we deal with every day. Again, I think there's a bit of that trust factor of how do we do that? How do we get our S&T community involved early to help us figure out what those really wicked hard problems are in building a very diverse architecture? So I think those are a few things that we're going to need to get there.
Yeah, well, I'll go on that as well. I mean, in terms of the diversity, so resilience through diversity, again, I think one of the areas building on that is from a commercial point of view is traditional competitors are going to have to start to work together. So things like looking at the US Space Force Enterprise Vision paper, that is all about moving from sort of siloed pieces where you're reliant on a particular terminal or a particular operator, and essentially they want to move to any network, anywhere, anytime. And so therefore there needs to be, as well as an S&T piece, there needs to be an understanding that different operators are going to have to support each other to support the customer at the end of the day.
That's great.
Jim, do you have anything to add from your side?
Supply chain is something that's really getting a lot of our attention now. Everything from the COVID pandemic that we are still have tail ends of that we're dealing with, to Ukraine, and to the fact that China can't ship us things as quickly as they once did. It makes for gaps and delays, which is something that when you're building a spacecraft, you never want. So can the U.S. solve that all by its own? Probably not. I think it's going to take cooperation and teaming between allies across the world to enhance the supply chain within their countries or groups of friendly countries, and share that with other partners throughout the world to be able to address that successfully.
And I mean, I just reflect on something both a couple of the panelists have said already, which I think, to reinforce it. I mean, our internal studies exactly sort of relay what Deanna has said about diversity in architectures, as well as other measures as well. That will lead to this protection of the system if we take that definition of resilience. But I think this resilience or diversity in the supply base itself and the industrial base itself, and having some idea about that, I think is incredibly important as well. And I think, one of the things we need to consider is if we are going to be able to collaborate internationally, if we're going to be able to collaborate in some deep S&T things, not only have we got some practical elements around things like information sharing, we also need to some extent a parity of capability, because we're going to make sure that we as the industrial base from the UK, when we come into that, we're not going to be the weak link, we're not going to be the weak chain. How do we make sure that we are bringing the right skills, the right technology, the right know-how? That means we're accretive to that team rather than taking from it. I think we need to really think about that. And again, it's one of those things that hopefully the space sector policy will be able to looking at as well, as how do we make sure that we have the industrial base to respond.
Absolutely, I hope so. Any more questions from the audience? Steve?
Hello, Stephen Byam, DSTL. With respect to the allied by design, secure by design interoperability, as an engineer, I see them as sort of subjective outcomes, but I want to understand them in terms of things that I can measure and things that I can understand. So as we move forward, say if we came back next year, the year after, what kind of objective activities, criteria would you see would enable us to say that we are achieving allied by design, we are achieving interoperability as we move forward?
I'll take that one on first. Yeah, see, I'll pick you up. Yeah. Okay. And I'll even try and use a Lockheed analogy. One of the things that we've discussed internationally is trying to perhaps not only be transparent, but look at standardization of what the interfaces are, right? So it's kind of the dream of Rome, right? What are those plug and play types of modules, right? And so if I, as a government person, want to acquire a satellite system, I, in theory, should be able to put an interface control document together, an ICD, and hand it to any of my contractor friends and say, look, bring me your payloads and I will fly. I'm happy to fly, right? So the analogy I would use is somewhat what Lockheed, I think, is doing with the F-35, and please correct me if it's not Lockheed, I'm not an air guy.
You're good. You're good so far.
Okay, good. Right. So Lockheed works with over 1,900 different companies, I believe, with the F-35. And they have an ICD for the F-35, right? So you have a weapons platform, and essentially, as you go to all the different allied nations, it's bring your own individual weapon systems that are unique to whichever mission sets you're flying. Right, so I find that as a very valuable example or exemplar for us to leverage, right? But that's challenging, right? And again, it gets back to my comment in terms of changing the paradigm. How do we do business? It's not always a great business case for some of our industry partners to, right? They have very unique systems, and that makes us reliant upon it. We need to move beyond those types of barriers, and we need to try and standardize how we do business. And so that's how I would try and address that question, I think.
And it feels only right that I carry on from there, because actually we've taken a similar approach in space as well. We've recently released the standards for a docking station, essentially, or a docking system we'll put onto our satellites called Aspin. It's been released now for people to look at, and that's a way of actually other manufacturers can create things that will then dock onto satellites that are already in orbit. And the idea is by releasing that as an open standard, people then can start thinking about, okay, we understand how we can create something that will then lock onto that system. That can be used for international collaboration because a friendly nation could be operating a platform, but they could bring on another payload even for a period of time, then remove it. But by releasing that open standard, hopefully that'll allow other people to collaborate. I think the other thing that I think would be an interesting challenge for people as well is, and I think it's across any mission area, but we're talking space right now, and it's one that's incredibly hard to get to, I know, but just something about setting standardization or agreements on requirements. Right now, we have a number of allied nations who are thinking about their future SATCOM capabilities. The question is, how closely aligned are the systems in their design and their requirement sets? I know there are discussions going on, but how far can you get to the point where those things are actually from the outset, from the early requirement stages, thinking about how they're going to complement each other and work alongside each other? I think that would be an interesting test. How many standardized requirement sets internationally might exist for certain missions?
Well, so at the end of the day, I think that synchronizes the North American industry base with the European industry base, right? And at the end of the day, we're allowed to have best athlete compete, right? I don't want to go to a particular vendor all the time because I'm relying upon that. So from a resiliency perspective, as I'm looking, it is who has the best capability that I want to fly that addresses a particular mission need. Right? And so I think that enhances the way that we do business, but it's also, again, it gets to that transparency piece and open comms between the government and our industry partners, but I'll also offer up that's also to our universities and academic partners, right? Because they're a critical player in terms of, hey, I've got a great widget I want to fly. Okay, here's the interface control document. Here's my ICD. Make it look like this and we'll fly it, right? Great opportunity.
Yeah, and I think we actually have a tool in our toolkit that we're using to actually be able to answer your question on what can we tell you to do. A couple of times it's come up today, and I know Natalie brought it up earlier, the CISPO initiative work that we're doing. So SSC co-chairs the Capability Architecture Working Group with Germany this year. Part of what we are doing is building a working group to define interfaces and standards, at least amongst the 7 nations. It's a big project, so we'll probably tackle it mission by mission or capability by capability. We're still trying to figure out how to do that. But I think actually doing the work to define those interfaces and standards that we can share with all of the partners, so we're all working from a common set of these, and share with our industry partners all over the world so that you've got something to build to. I think that work is getting ready to start right now, so hopefully we will have something that we can hand over fairly quickly to get after that.
And we're trying to leverage that on the NATO side as well. So take what's done under Five Eyes plus 2, make it extensible under the S&T umbrella to all of our NATO partners as well as our enhanced opportunity partners. Those are our non-NATO partners that are part of the S&T umbrella. So that's Australia, New Zealand, Finland, Sweden, Japan, right? Similar like-minded allies, right? So leverage what's been done. Don't recreate the wheel, but take what's been done, build upon that, and enhance that and push that forward. Again, that's part of the innovation that we're looking at. We just have to be more efficient and smarter with how we do business.
Ben, do you have anything to add from your perspective?
Yeah, I think it's also having those discussions with the customer and seeing if there's a hole in their capability or a hole in their commercial model that industry can help with. So I think a good example in terms of that partnership is with Space Norway, where Inmarsat, Space Norway, and US government have all teamed together to launch highly elliptical orbit satellites to provide Arctic coverage in multiple different bands. But probably each of those actors couldn't justify that expense and cost by themselves, but together it's able to do that. So I think that type of collaboration is really important.
Jim, do you have any additional comments to that?
No, that the type of cooperation is going to be critical, reaching out to Norway and other countries throughout was going to help things on the supply, also on the supply chain, because you have different access to materials and supplies in different parts of the world, and having allies cooperate together on that is going to be very, very helpful.
Right, thank you. I think in the interest of time now, we'll have to wrap up, but it's been an incredibly exciting and energetic discussion that I wish could go on for a few more hours. I may probably be the only one left here, but I want to just summarize quickly some of the key points. First, we need to empower our leadership in S&T and in operations and make sure that we have that trust at an international level. And the only way to do that is really to communicate and communicate clearly. Even though American English and English is different, we have to overcome those sort of things. And the key thing is, what are we trying to go for? We're trying to long-term go for allied by design, integrated by design. The only way that we do that is to communicate and collaborate effectively. Thank you very much, and I want to thank the panel. So please, if you can, thank the panel with me, and thank you for the time.